Hey class, so today we're going to be going over sketching graphs of this form y equals a sine x and y equals a cosine x. So the a here stands for just some number. So for an example, we might want to see what y equals 2 sine x is. And we want to see how this 2 is going to change our function and the way it appears. So this a is called the amplitude, and let's just jump into the notes. So there are 4 factors in total that affect the graph of a sine or cosine curve. And the first one is amplitude, what I just called that number multiplying our function. And this amplitude is going to affect the range of our function. So remember that we went over for sine and cosine, the range of our function is -1, 1. So if this a is now our maximum, you can see that the range then changes to -a, comma, a. So by multiplying our sine or cosine function, we're basically stretching it out, making it taller in both directions. And one important thing to notice is that the amplitude is measured from the x-axis to the highest point. And this is why in the definition of the amplitude, it says it's the measure of half the distance between the maximum and minimum values. So you can think about it like the height of a building, the height of anything, right? You measure it from the ground. You don't measure it from here to here. So we're not measuring this distance. We're just measuring this distance. Okay, so let's keep going in these notes. So here I want you to try to compare the graphs y equals sine x and y equals 2 sine x. So you can use the 5 quarter points, which I suggest you do, and then also use desmos.com/calculator, because that'll give you kind of a better picture of what these two graphs will look like. Okay, so here are the two graphs y equals 2 sine x and y equals sine x, using both the 5 quarter points and desmos.com. So as you can see, we have the same values in both of these comparisons. So these are creating the same picture. You might be wondering, how did I get all of these values from the 5 quarter points, which you may or may not recall from the last lecture. So let me just highlight what those were. So for the sine function, the 5 quarter points, we just draw like really quick sine graph. The 5 quarter points were 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. So the way we can use these points to figure out what 2 sine x looks like, remember that 2, our amplitude, is only changing the maximum and minimum. So our max and min changes to -2 and 2. So looking at our 5 quarter points, these 3 points, where they're at the 0, are going to stay the same. The only points that are going to change are going to be this point and this point. And the only thing that's going to change about these points is the pi over 2, 1 becomes pi over 2, 2, and our 3 pi over 2 negative 1 becomes 3 pi over 2 negative 2. So then when we draw it out, we just get a graph that's a little bit steeper. These 3 points are the same, but now this point reaches a height of 2, and this point reaches a depth of negative 2. Okay, so let's move on. For our next example, we're not going to be, well, I guess we are sketching the graph, but the first thing I want you to do before you sketch the graph is just determine the amplitude and range. So here we have negative 2 over 3 cosine x, and I want you to find the amplitude and range of this function. Okay, so here we have the answer to that example. The amplitude is 2 over 3, and the range is negative 2 over 3 to 2 over 3. So this might not have been something I highlighted, but let me go ahead and do that here. In the definition, it defined the amplitude as the absolute value of A. So I'm trying to think of an analogy, but just remember that when we talk about distance, so the length of something, the distance away from something, whatever, we might be talking about, this is always going to be a positive number. And the amplitude is kind of the same in that regard. Since we're measuring the distance between the x-axis and the tallest height, right, that's going to be a positive number. So whenever a question asks for the amplitude, it's always going to ask for the absolute value of the number multiplying your cosine or sine function. And then the range, again, is just going to be that A multiplied by negative 1. So this is going to be absolute value of A times negative 1, and then the absolute value of A times 1. And that'll be the range. Okay, so let's go ahead and show the graph. But before I show the graph, I would encourage you to pause the video, try to find it using the 5 quarter points, and then also comparing that to Desmos, or to the graph of it on Desmos. Okay, so this graph is a little trickier because we're dealing with a negative right here. So because we're dealing with a negative, what winds up happening is this 1 on our first quarter point becomes a negative 2 over 3. Now remember, the zeros are going to stay the same, so these don't change at all, these 2 points. But now this negative 1 becomes a positive right here, and this positive becomes a negative. So the negative amplitude flips the graph. So a negative amplitude flips the cosine graph. Kind of like inverts it, if you will. The positives become negatives and the negatives become positives. Just like regular numbers, when you multiply a negative by a negative, you get a positive. When you multiply a positive by a negative, you get a negative. So we can compare this. I believe I have Desmos on the next one. Yep, there it is. And one thing I do want to highlight is Desmos, for some reason, likes decimals instead of fractions. So if you were trying to kind of do this first and then kind of revert back to a hand drawing with actual numbers and not fractions, you might have had a hard time with that. So try to do it with the 5 quarter points. That's something that you should get used to, and something that you should be able to do on a test or a quiz. So here we have the mathematical verbiage of what this amplitude is doing. So this f of x is just a stand-in for some general function. This could be a cosine or a sine. So this is just a general thing. So when a is positive, we say that the amplitude is vertically stretching our function. And it's stretching that function by a. So this is like the first example we went over. When we have sine versus 2 sine is vertically kind of taller and more shallow than just sine of x because it's being stretched vertically. When a is less than 1, we say it's vertically compressing our function by a factor of a. And this compression involves reflecting the graph about the x-axis. So reflecting the graph about the x-axis is, let's say our graph looks like this. Just take a simple example. So reflection makes our graph look like that. So it's just like kind of if you were looking in a lake or a puddle and you saw your reflection, right? You're flipped upside down. This negative amplitude causes the graph to reflect across the x-axis. That's important. So it's changing the size of the graph, but it's also reflecting it. So it's a two-step process. Okay. And that is all I have for this lesson. I'm going to move on to the next set of notes, which deals with period shifts. Okay, so in this part of the lesson, we want to talk about sketching graphs of the form y equals sine b of x and y equals cosine b of x. So this b is technically inside the parentheses. So it's multiplying whatever input that we put into the function. So typically, if we just put some angle in this function, like let's say pi over 2, that's easy enough. We can look at the positive y-axis, and we see that sine of pi over 2 is just 1. However, if we're dealing with, let's say, sine of 2x, and we want to put in pi over 2, well, now we have to simplify this first, so we do 2 times pi over 2, which is equal to sine of pi, and this now is going to give us 0. So by adding this b, what happens is that our inputs give us different outputs, right? So these are the same inputs. Both of these x's are just pi over 2. And but we're getting different outputs now. When at first we got 1, now we get 0. So we want to try to understand generally what this b is doing to our function. Okay, so let's ask the question, what is b doing to our function? Okay, so remember that the first cycle of sine x and cosine x fit between 0 and 2 pi. So before, on our xy axis, we can do sine here. This point right here, marked 2 pi on the x-axis. So this was one whole cycle. And this is the period, is 2 pi. But now what we're doing is every point on this graph, we're multiplying it by b. So now this point is b times pi over 2. This point right here is b times pi. And since we're multiplying, I'm sorry, maybe I should make this clearer. We're multiplying the x inputs by b, not the actual y outputs by b. So I want to make that clear. So this changes our graph, and this changes our graph pretty significantly, or just in a different way than the amplitude did. So before we had x, just being between 2 pi and 0, but now we have bx, and that is going to be what's between 0 and 2 pi. So how do we say what our inputs are going to be, or when the repetition is going to occur? And when we do just a simple arithmetic of dividing both sides by b, we get that x is going to repeat after 2 pi over b. So that means that when we do a complete cycle, this point is now 2 pi over b. Just to possibly help clear up any confusion, let me write down sine of x and sine of b times x. Okay, so these functions should repeat at sine of 2 pi. So these functions should reach this point at sine of 2 pi. Okay, now in order to get this sine to reach sine of 2 pi, we just simply make x equal to 2 pi, right? So 2 pi equals x. However, to get this point to 2 pi, we have to plug in x is equal to 2 pi over b. Because when we plug in 2 pi over b, the b's cancel out and we get sine of 2 pi. So our x is now 2 pi over b. Okay, so I hope this kind of clarified things and didn't confuse you more. But the basic principle is that this b in our cosine and sine function right here will change the period of the function. It'll change how far along the x-axis it goes before it repeats. And there's a graphic on the next slide that hopefully clarifies it a little bit. So b alters the period of our function. So the period is now 2 pi over b, where b is greater than 0. So you can't divide by a negative, or I'm sorry, can't divide by 0. So b is going to be greater than 0. Yeah. So this is what our graphs look like. The major change is our endpoint here. For the first cycle is now 2 pi over b. And that goes for both sine and cosine functions. Okay, so let's look at an example. Okay, so this is a lot of words, but just stay with me for a second. So for b greater than 0, we can plot the 5 quarter points by subdividing our graph into 4 equal intervals of length 2 pi over b divided by 4. So the quarter points, remember, we can just do sine really quickly. The quarter points were divided into sections of pi over 2, right? So this was pi over 2, this one was pi, this is 3 pi over 2, and this is 2 pi. So this regular sine function, its quarter points were just subdivided by 4 pi over 2. So this is why we had pi over 2, pi, 3 pi over 4, 2 pi. we divided it into 4 sections. So since our endpoint has now changed from 2 pi to 2 pi over b, we're now dividing this by 4. So we'll get pi over 2b sections. So our x-axis will be divided into pi over 2b, pi over b. Sorry, I'm kind of running out of space. Pi over b, 3 pi over 2b, and 2 pi over b. So those will now be our quarter points. Okay? So I gave you an example here. If we have 2x, that means that the first section right here, this first subdivision, okay, let me just go down for a bit. So if we have y equals sine of 2x, when we subdivide it, our first point is going to be plugging 2 into this, just pi over 4. Our second point right here is going to be pi over 2. I'm just plugging in 2 for b. Our third point is going to be 3 pi over 4. And our last point is going to be pi. And that's what I have written up here. So the 5 quarter points would be this right here. So 0, 0, pi over 4, 1, pi over 2, 0, 3 pi over 4, negative 1, and pi 0. So notice that what we were doing before when we multiplied the sine graph on the outside, we didn't change any of the angles, we just changed the maximum and minimums. So we changed the 1s to a and the negative 1s to negative a. Here we're leaving the y coordinates alone, we're leaving the outputs alone, and we're just changing the x inputs, so the angles that were associated with these 5 quarter points. So instead of 0, pi over 2, pi, 3 pi over 2, and 2 pi, we now have pi over 2b, pi over b, 3 pi over 2b, and 2 pi over b. Okay. And since 0, when you divide it by b is 0, we leave this point completely alone. So, okay. Let's move on to some examples that we can do. So yeah, this is just the graph of 2x, just to highlight what this looks like. So I made this graph out to 2 pi. That's 2 pi right there. And notice that before, our sine graph looks something like this, where it filled up the entire 2 pi. But now we fit 2 repetitions inside of 2 pi. We have one repetition from 0 to pi, and then another repetition from pi to 2 pi. So by multiplying the 2, or the x by 2, we've multiplied the number of times it will repeat between 0 and 2 pi. So this has now repeated twice between 0 and 2 pi. Okay. All right. So if we look down here, we'll see an example that I want you guys to try on your own. So here we have 2 examples, but I want you to focus on this A example first. So I want you to determine the period of cosine of 1/2 x, and then I want you to sketch the graph. So again, I want you to sketch the graph trying to use the 5 quarter points first, and then I want you to compare that to a Desmos graph of it. Okay, and here we have the solution to this problem. So the first part, the period. So remember that the period is now 2 pi divided by b, and our b in this case is 1/2. So 2 pi divided by 1/2 is equal to 2 pi times the reciprocal of 1/2, 2/1. So the period is now 4 pi. That's what we have written here. So since the period is 4 pi, that means that one cycle is going to fit between 0 and 4 pi. And if we want to graph this, we want to divide all of our, we want to divide 4 pi into 4 equal sections. So then we have 4 pi divided by 4, which gives us pi. So that means the quarter points are now going to have inputs of pi, 2 pi, 3 pi, and 4 pi. As always, we keep the 0 the same. And that's what I have written down here. So the outputs of these quarter points stay the same as always, or not as always. The outputs stay the same because we're not changing the amplitude in these examples. We're simply changing the period. So the max and min is still 1 and -1. And this is what it looks like when you graph it with Desmos. And again, I've just highlighted the 4 quarter points, or 5 quarter points. Okay, so I want you to try to do y equal to sine pi of x on your own. Again, you can always use Desmos as a way to check your work and see how well you did. And then the last slide I will leave you with is going to be compressing versus stretching. So remember that amplitude horizontally, or sorry, not horizontally, vertically stretched or compressed our graphs. Here we're going to be dealing with horizontal compressing and stretching. So when b is greater than 1, we horizontally compress it. So this is like when sine of 2x, right? So that meant it repeated twice in 2 pi. So we kind of squished it inward this way. Right? And then we divided each x coordinate by b. This is just the generalization of what we did with the 5 quarter points, how we divided it by b. For b that is a fraction, like the 1/2 that we did, this is going to horizontally stretch our function f of x. So in our cosine 1/2 of x example, we saw that it repeated after 4 pi. So it took a lot longer to repeat. So the fractional period shift horizontally stretches our function. And this is just a reminder that dividing by a fraction is the same as multiplying that fraction, multiplying by that fraction's reciprocal. So, example, x divided by 1 over b is equal to x times b. This isn't a negative. This is just kind of like a dash saying, for example. So maybe that was confusing. Maybe I shouldn't have put that there. But yeah, that is it for period shift as well as amplitude shift. So let me know if you have any questions, and I'll see you next time.